For this example, we want to now solve a system of linear equations, but we have three equations this time and actually three different variables. So this problem is going to be a little bit harder than the previous lesson, but not because the concept is difficult, it's just very easy to make a mistake. But we're going to take the same approach where I'd like to reduce this down to two equations with just two variables. So ideally, I'm going to try to cancel either all of the x's, all of the y's, or all of the z's. There are multiple ways to do this, so I'm just going to go with one and see what happens. I think what I'd like to do is cancel the x's. This might not be the fastest way, but I know if I multiply the first equation by -2, it'll then cancel with this 2x. If I then multiply this first equation by -3, it'll cancel with the second equation. So same type of idea, just several more steps. So let's do that very first one where I'm going to multiply the first equation by -2 in an effort to add it to the second equation. Let's see what happens. I get -2x plus 4y minus 2z is equal to -6. I think that's all right. And I'm just going to copy down the second equation, not going to change it at all. All right. So I'm doing this so that when I add them together, I'm canceling at least one of the variables. And what do you know, the x's cancel. I'm left with 5y minus z is equal to -2. So the x's are gone. I have a y and a z. I would like a second equation now with just y's and z's. So again, the way I'm going to do that is I'm going to multiply the first equation by 3 and add it to the third equation. So I'll do that off to the side. Let's see what we get. So again, multiplying this by -3 is going to give me -3x plus 6y minus 3z is equal to -9. And then I'll simply just copy down the third equation. So I'm just working with this last one. I'll write it right below here as 3x plus 4y plus 3z is equal to -1. So same idea now. I'm going to add the left and the right sides and see what we end up with. Okay. Well, the x's cancel. I have 10y. I have, oh, the z's cancel as well. That's kind of interesting. And on the right, I get -9 minus 1, that's -10. And here we go. 10y is equal to -10. I can now, almost immediately solve for what y is equal to by dividing both sides by 10. Y is equal to get that fixed here, -1. So I still haven't worked with this equation yet, but I know y is -1. This is going to allow me to solve for z, so let's do that next. I have 5 times -1 minus z is equal to -2, or -5 minus z is -2. Adding 5 to both sides gives me -z is equal to 3, and dividing both sides by -1 gives me z is equal to -3. So I have my y, I have my z, but just as in the previous lesson, now that I have three variables, I have to get a value for x as well. So I know y, I know z, I just don't know the corresponding x. But as long as you choose an equation that has all three of those variables, you can solve for it. So I think I'm just going to, like last time, just go back to this first one. I'm going to put -1 in place of y, -3 in place of z, and that will allow me to solve for x. So let's work that out below here. I don't know my x. I do know that it's -2 times -1 plus -3 is equal to 3. Or x plus 2 minus 3 is 3. So write x minus 1 is equal to 3. X is equal to 4. And technically we're done. I know the x, the y, and z that make all three of these equations true at the same time. But you can also write your answer as, well, I know that x is 4, y is negative 1, z is negative 3, and the answer can be expressed just like this. And like I said, there is more than one way to do this. Like, maybe you could have subtracted the first two equations to cancel the z. Like, it'd be fine to try that. In fact, I encourage you to give that a shot, but this is just one way to solve this problem. And for the last example here, same idea. I have three equations, three different variables, x, y, and also z, and I want to find the x, y, and z that make all three equations true at the same time. Now, there are so many variations on these types of problems, and this problem looks a little bit different than the first one. I noticed that each of the three equations only have two of the variables present in them, but we should still be able to use the same ideas, so let's see what we can come up with. Let's see, so maybe I'll try to cancel the z's. I mean, I don't know, I'm just kind of going with that. So if I look at the first two equations, they both have a z in them, and I'd like to cancel them when I add the two equations together. We have negative 4 and positive 3, so I can't just simply add them, so I'm going to have to be a little bit careful here. I think what I'm going to do is, I'm going to take my first equation, I'm going to multiply it by 3. I'll take my second equation, and I'm going to multiply it by 4. In doing this, I think it's going to make it so that the coefficients in front of the z's are now equal but opposite in sign. So let's see what happens. Multiplying by 3, I get 9x minus 12z is equal to negative 3. But in the second equation, I get 8y plus 12z is equal to 8. So there we go. All right, let's see what happens when we add these together. So yeah, the look of this one is definitely different, but if I add the left sides, I get 9x, and I have 8y, which are not like terms, they can't be combined, but I have a negative 12z and a positive 12z, which cancels. And on the other side of my equation, I get positive 5. So here we go. I have 9x plus 8y is 5. All right, what I'd like to do now is use my final equation. I haven't used that yet. It has to be used somehow within this question. This one is 2x plus 3y is 6. I'm just going to simply write that below this first equation that we came up with. So 2x plus 3y is equal to 6. So the question now really is, I'm solving this thing. I want to find an x and a y that make both of these true at the same time. So let's see. I think I'm going to try to cancel maybe I'll try to cancel the x's. So again, to do this, I'm going to multiply both equations by some number. So I'll work across here. So I have a 9 and a 2. I think what I'll do is multiply the first equation by negative 2. I need a negative because both of the numbers are positive. One has to be negative for when I add these things together. And I'll multiply the second equation by a positive 9. Let's see why this should work. If I multiply by negative 2, I get negative 18x minus 16y is equal to negative 10. But in my second equation, I get positive 18x plus 27y is equal to 54. Great. If I add these together now, it'll cancel the x's, and actually I'm just left with the y's. All right, I have 11y is equal to, oh, that's nice, this is going to be a positive 44, so that when I divide both sides by 11, I am left with my y value of 4. So all we need now is the corresponding x, and then I need the corresponding z is the only other thing that we don't have. So this time, I need to look for an equation that has both an x and a y in it, and no z. This will allow me to solve for x. I'm going to choose 2x plus 3y is equal to 6. So let's see what happens here. I get 2x plus 3 times 4 is equal to 6. So 2x plus 12 is equal to 6. Subtracting 12 from both sides gives me 2x is equal to negative 6. Dividing both sides by 2 gives me x is equal to negative 3. Okay, that wasn't so bad. And now if I need the corresponding z value, I can use any equation that I'd like as long as there's an x in it. So I'm going to go right back to the very first equation. 3x minus 4z is equal to negative 1. I'll put negative 3 in place of x, and that will allow me to solve for z. Well, let's check it out. I get 3 times negative 3 minus 4 times z is equal to negative 1. That's negative 9 minus 4z is negative 1. Adding 9 to both sides gives me negative 4z is equal to positive 8. And then dividing both sides by negative 4 gives me z is equal to negative 2. And this is it. I know the x, the y, and the z value. Maybe I'll go over here and write the point where this is true is x equals negative 3, y is equal to 4, and z is equal to negative 2. And this coordinate, this x, y, and z point, makes all three equations true at the same time.